Hey, how's it going? Nick here. I thought I would go ahead and make a quick video and run through the development of a class similar to the even class that we're going to make, but just to kind of like give some actual code examples of defining a constructor and some methods and using those and so on. I'm going to make a class. I'm going to call it fraction, F-R-A-C, and this is going to be a class for basically manipulating fractions of two integers. And it's not going to be very fancy. This is just to kind of give an idea. So I'll make my fraction class named frac. I'll call it public class fraction. So that's defining, this class. I'm not going to put a main method in here because this is just a class that's going to be used inside a main test program. And what do we need to represent a fraction? Well, we basically need a numerator and a denominator. And they can both be integers, right? If we have a fraction like 2/3, we just need to remember the numerator is 2, the denominator is 3. So I'm going to make a pair of integers, and I'm going to make them private. So private int top, comma, bottom. Okay, and those are going to represent the numerator and denominator of my fraction. Okay, I'm going to make a constructor. And most obvious way to construct a fraction is to tell me what you want on the top and the bottom. So public fraction, integer t and integer b. So we're going to construct this as, for example, new fraction 2 comma 3 to make the fraction 2/3. Okay, so what do we have to do when somebody tries to construct a fraction? We just need to remember the numerator and denominator. Well, I have a pair of class variables here called top and bottom. And if somebody wants to make a fraction 2/3, they're going to call this constructor. T is going to be equal to 2, b is going to be equal to 3. So I'm just going to save these in my variables up here at the top. So I'm going to write the following. Top equals t, bottom equals b. And that's really all we have to do in our constructor. Now we don't have to return anything because since it's a constructor, okay, we know it's a constructor because its name is the same as the name of the class. So we don't specify a type of return. It's returning an even, right? But we don't actually say return. Fractions are not methods in the usual sense. So there's a constructor for the fraction, and we could make, a constructor that just takes one number and sets it equal to that number over 1, and so on, but we'll keep it simple for now. Okay, and let's just leave it at that, and let's make a main class with our favorite public static void main, parentheses, string, bracket, bracket, args. And let's look at how we would use these fractions. Okay, so we might say something like this fraction f1 equals new fraction 1 comma 2. So f1 is the fraction 1/2. And we might make a fraction f2. And let's say f2 equals new fraction, let's make it 2/3. Right? So up here I declared my object f1 to be a fraction in the same line that I constructed it. Over here I've declared my fraction f2, but then I constructed it in a separate line. Okay? You have the option of doing whichever you like. So let's make a fraction f3, or let me call it x, just so we don't think f is magic. So f is a temporary variable. And now I'm going to multiply f1 and f2. So I'm going to say x equals f1 dot multiply f2. Okay, this is the thing that's tripping some people up with with our even class, right? We're multiplying two things. One of the things we're multiplying is f2. We pass that as an argument to the multiply method. The thing we're multiplying it by is f1. How do we know that? Because f1 is the thing from which we're calling the multiply method, right? We're calling f1's multiply. Well, f1's multiply multiplies its argument by f1. Okay? haha.multiply says call haha's multiply, and it will multiply its argument by haha. Okay? Think of f1 as a fraction. Think of it as having a numerator and a denominator, a top and a bottom. f1 is a fraction. This fraction's multiply method says multiply the argument by f1. So x should be equal to f1 times f2, which should be 1/2 times 2/3, which should be equal to 2/6. And I'm not going to reduce things to simple form here. So let's print out what the value of x is. And so we'll just print it out like that. So there's our main method. Okay, so let's go back to our fraction class and let's define this multiply method, and then let's figure out what to do about the print line. So we'll go back in here. So we're going to multiply whatever the object value is, the fraction represented by the object. We're going to multiply that by the argument of this method, and we're going to return a new fraction. So this is a public fraction named multiply, which takes a fraction, which is just an argument. Okay, so how do we multiply two fractions? Multiply the numerators together, multiply the denominators together. Okay, so let's say integer, the resulting top should be equal to the top of this object, which is top, times whatever the top of the argument is. So, I'd like to say argument.top, but that's not going to work for a moment. So result bottom equals my bottom times argument bottom. So we'll come back and fix these up in a second. Then we're going to say even result equals new even. Sorry, I'm thinking evens. Fraction result equals new fraction. And what should the numerator of this new fraction be? Result top. And what should the denominator be? Result bottom. And then we're going to return result, which is a fraction. Right? So mul is supposed to return a fraction, so we're going to return result. Result is a fraction we constructed whose numerator is the product of this object's numerator and the numerator of the argument. And the denominator is the product of this object's denominator and the denominator of the argument. Okay, so this would work perfectly, except that we've made top and bottom private. So if I try to do arg.top, the compiler is going to tell me that's a private field, you don't have access to it. So we're going to make a pair of accessors. Okay, this is like the toInt function in even. So instead of arg.top, I'm going to say arg.getTop. I'm going to use a method to read this restricted field. So arg will have access to its top and bottom, right? Because those are fields inside the class. And so I can write a method inside fraction to get the top and the bottom. So let's do that right now. So let's make a pair of accessors to let others see what the value of the top and bottom is. Alright, make a pair of accessors for letting others see top and bottom. So these are going to be public. We're going to return integers. Get top does not take an argument, and it just returns top. Okay, that's all there is to it. It's almost not worth writing this because all it's doing is just reading a field and returning it, right? But we need to do this because this field is private. And somebody else, including another instance of this class calling the multiply method, can't get to a different object's top or bottom because they're private. But it can get to an object's getTop method because that's public. And getTop as part of an object has access to that object's top and bottom because private means things outside the class can't access it, outside of the object, but things inside can. Okay, that's a little weird to think about, but think about it. So here's our getBottom accessor. And let me be better about these names. Let me call this getBottom, and let me call this getBottom. And typically, when you make an accessor for a variable named, something, you call the accessor get something, but you capitalize the first letter of something, so it's the usual camel case. So the accessor for bottom really should be called getBottom, like this. So we'll be consistent about that. Okay, now we have a pair of accessors. This should compile, other than, typos like that. So bottom equals bottom. Okay, and if I compile main, so it's a fraction, not a frac. Okay, so that compiles. And if I run this, it runs fine, but when I print x, right, we get the funny output where it shows us the name of the class, an @ and then a hexadecimal address. So let's make a toString method. Okay, this is also part of the even class. So return a nice version of the fraction as a string. So this has got to be public. It's got to return a string. It's got to be called toString in camel case with no arguments. So let's just return the top plus a slash plus the bottom. Okay. So now when we try to concatenate an object of type fraction to a string, the JVM will call that object's toString method. The toString method will take the top, the bottom, turn them into strings, put a slash in between. So 2/6 should come out as a string 2/6. That gets returned from the toString method, and that gets concatenated here to x equals, and so we should see x equals 2/6. So let's compile frac.java, and let's go ahead and run main, and there's our result, x equals 2/6. Okay, that basically shows you the essential elements for programming assignment 1, the even class. Different class, different behavior, and so on, but we have the ability to construct. We have the ability to call methods that take an argument and operate on that argument and the object that we're using to access that method. And there's a toString method. All right, so here's fraction.java. There's the constructor. Here's the multiply method. Here's a pair of accessors. And here's the toString method. All right, so look at this. Don't just take this and edit it and turn it into even, but use this to try to understand the mechanics of constructing, in particular the mechanics of operating on an object and an argument. What's going on in here, right? Think about that. And just an example of how exactly this toString method can be used. So take a look at that, play around with it, write a lot of code, make a lot of mistakes. That's how you learn stuff. All right, thanks. All right, I will catch you later.